So now in this lecture we will discuss about add instructions and few examples which are related to add instruction. Now during the add instruction we will add two numbers, and when we are adding two numbers, then one number must be in A register. So the mnemonic for add instruction is ADD, add. Now with add instruction we require two operand because two numbers we will add, and one number must be in A register. So here we will write A, comma, and the second number which we are going to add with the content of A, it can be in register, or we can mention the address of that number, and we can also use @RI, and also we can use the immediate number. So basically this add instruction is having four forms. So the first form is add A, comma, Rn. So here n is 0 to 7. So when we are adding two numbers, then first number must be in A. In this we will just bring first number, and second number must be in any of the register like A, R0, R1, R2 or up to R7. So here we will have second number. So this instruction, what it will do, it will perform the addition between content of A and content of the register, and whatever is the result, 8-bit result, this result is again stored in A register. So whatever is the result, that will be stored in A register. So after addition you will find that your first number which was in A register, that has been replaced by the result. So example for this instruction is add A, comma, R0. So in this case content of R0 register will be added with the content of A register, and finally you will find the result in A. Now the second form, so this is the first form. Second form is direct address. You can write the instruction in this way: add A, comma, 30H. So now what will happen? When you are adding two numbers, first number is in A register and the address of second number is 30H. So this 30H is the address. So our second number is in RAM, and in RAM it is at location 30H. So that particular content will be added with A, and final result will again stored in A. Now the third form of this instruction is add A, comma, @R0. Now in this case the first number as usual is in A register, and the address of second number is pointed by R0. So whatever is the value of R0, that value will specify the address of second number. So that number will be added with A, and final result will be stored in A. So here in place of R0 we can use R1 also. For example, add A, comma, @R1. So only these R0 and R1 is allowed with this @ symbol. Now the fourth form of this instruction is with the immediate number addition. Add A, comma, #30H. So now the first number is in A register and this is your second number. So the content of A will be added with 30H. and whatever is the result, that will be stored in A. So just you see these two instructions. The difference is between these two is only the absence of hash symbol. So here this 30H is the address where our data is stored, and that data will be added with A. And here, since we have placed the hash symbol, this indicates that this is the data. So 30H will be added with the content of A register. So these are the four forms of add instruction. Now we will see one example. Suppose we have three numbers, and these numbers are stored in internal RAM from location 30H. So we are having at 30H, we have first number at 30H, and we have one 8-bit. So all these numbers are 8-bit number. We have second number at address 31H, and we have one third number at address 32H. So these numbers are 17H, 23H, and 43H. So we have to add these three numbers, and whatever is the result will be 8-bit, and result we will store at memory location 40H. At 40H we will store result. So this is our set 1. This is our set 1. And after performing this addition, we will apply a new set of data. The data will be stored at same locations only, and we will perform the addition for that, and for set 2, and again after set 2 we will perform the addition on set 3. There will be 3 data set, and in second data set we have first number C4H, then second number is 34H, and third number is 72H. And in third set we have C4H, first number, second number is 94H, and third number is B2H. So we have taken 3 different sets, and my aim here is just to see when we are adding 3 numbers and when carries are generated, then what effect will be there, how we will treat those carries. So first we will write a program in which we will not consider the carry. So we will write the program with org directive 0000H. Now the first instruction, what I will write, I will bring the address of my first number in R0 register, because I know that in future I am going to use register indirect addressing mode. That's why I am loading the address of my first number in R0 register. We can use R1 also for register indirect addressing mode. So the instruction is move R0, comma, hash 30H. So now with this, the address of first number, that is 30H, is in R0 register. Then I will write the second instruction. In this I will use another register R2, and in this I will load 02H. My this value, this 02, which is stored in R2 register will act as counter, which will tell me that we have completed the addition of all the three numbers. So the logic which I am going to use in this program, in that particular logic, if I want to add three numbers, then I have to take the counter one less than that is 2. If I have to add 5 8-bit numbers, then I will take the counter 4. So total how many numbers I am going to add? I will take counter less than 1 from that number. We can use another logic in which the counter value will be equal to the total numbers which I am going to add. So there are many ways to write a program. So in my logic, I will take the counter value 1 less than the total numbers which I am going to add. That's why I have taken here 0. Now I will bring my first number in A register, because we know that, since I have to use this instruction, add A comma at the rate R0. I know this, and I know that this instruction I am going to use. So my one number must be in A, and address of my second number should be in R0. So first I will bring my first number in A. So for that I will write the instruction move A comma at the rate R0. So with this what will happen? The value of R0 will define the address. So what is the value of R0? In R0 we have loaded 30. So 30 is the address now. From 30 address, whatever data is there, that will be moved to A register. So at 30, so we are now considering the set number 1. So at 30 address we are having 17H. So what will happen? In A register, now we have 17H. So now first number is in A register. Now I have to bring, so basically, I will leave one space for one instruction that I have to write here. After that I will write this instruction add A comma at the rate R0. So basically what this instruction will do, it will add the content of A, which is 17, the first number, with the content of the memory whose address is defined by R0, means that is my second number. So what is the address of my second number? Address of my second number is 31. So when this instruction is executed by the controller, at that time the address of second number must be loaded in R0. So how to load that instruction? So I will use here one instruction INC R0. So now what this instruction will do? It will increase the content of R0 by 1. So at this particular time, what is the content of R0? Content of R0 is 30H. So now with this instruction, content of R0 will become 31H. So here the content of A will be added with the content of memory whose address is defined by R0. Now in R0 we have 31. So 17 will be added with 23 now. After the addition, so 17 will be added with 23H, and after the addition the result is 7 plus 3, 8, 9, A, 2 plus 1 is 3. This is the result, and this result you will find in A register. So after this instruction you will find in A 3AH, which is the addition of first two number. So this is our first number and this is our second number. So we have completed the addition of first two numbers. Now what we will do? Now we will check whether we have completed all the additions or not. For that we will decrease this counter D, J and Z. decrease, jump, no zero, R2 and back. Go to the label back, and label back is here. So earlier the value of R2 is 0 to H. Now with this instruction, the value of R2 will be decreased by 1. So now R2 will become 0, 1 H. So if the value of R2 is non-zero, go to label back. So since it is 0, 1, that's why program will go to label back. It will come to this place. Now here INC R0. So again it will increase the value of R0 by 1. So what was the value of R0 previously? 31. And now it will become, so now R0 will become 32H, which is the address of my third number. So now address of my third number is in R0. In A we already have the addition of first two numbers. So in A we already have 3AH. Now this instruction is executed. So now with this instruction, this value, which is the content of A, will be added with third number, 43H. So here 43H, this addition will take place. And what is the result? A plus 3, B, C, D. This is D, and 4 plus 3, 7. So this is the value 7D, and this will be stored in A after the addition. So finally, add A, comma, add the rate R0. After this you will find in A 7DH, which is the addition of three numbers. So we have completed the addition. So we will verify this whether we have completed or not with the help of next instruction. So this is D, J and Z R2. Now the value of R2 will be decreased by 1. So previously R2 was 0, 1, it is decreased by 1, so it will become 0, 0H. Now if it is 0, 0H, then come out from the loop. So program will come out from the loop and program will come here now. So when program will come here, at that time we know that after we have completed all the additions and our final result is in A register. So this final result we have to store at 40H at that location. So simply here I will write the instruction, move 40H, comma A. So the content of A, which is 7DH, will be stored in 40H. That's all. So and in the last H jump here, we will come to here. In this way, or these particular set of instruction will perform this operation. So here we will get a result. So this is for, and result is 7DH. Now if we perform the addition of second set, if at these locations 3H, 30H, 31H and 32H, if we have loaded these set two numbers C4, 34 and 72, then what result we are expecting and what result we will get. So basically we are expecting a result C4 plus 34. What it will give? It will give 4 plus 4 is 8 and C plus 3, D, E, F. So this will give you F. This is the result after adding first two numbers, and in that I have to add the third number 72H. Now when we are adding this number, 8 plus 2 is A and F plus 7. F plus 7 is 0, 1, 2, 3, 4, 5, 6. 6 here and one carry will be generated, and this is the carry. This is the carry. So after adding these three numbers, our result should be 1, 6, A, H. This should be our result. So basically our result is more than 8 bit. That's why, and this value 6A, this value you will find is stored in A register in the accumulator, and this due to this carry, you will find carry flag is 1. But if we use this set of data for this program, then at address 40H, we will find a result 6AH. So this basically is in A register, and with the help of last instruction, whatever is there in A, that we have transferred to memory location 40H. That's why at 40H we will find 6A. But our real result which we are expecting is 16A. So basically if we will see the result in 40H memory location, we will get 6A. That's all, and that is not the correct result. So in this particular program, since we have not considered the case when while addition carry may be generated, that's why we are not getting the correct result. Now what is the result when we apply third set of data? In third set of data, when we are adding first two numbers 64H and 94, then the result is 4 plus 4 is 8 and C plus 9. DEF 0, 1, 2, 3, 4, 5. 5 with 1 carry. So 1 carry will be here. So this is single bit, right? This is the hexadecimal number. Now this is the result of first two numbers addition, and with this we will add the third number, and third number is B2. If we add this, 8 plus 2 is A, and B plus 5, C, D, E, F, 0, and here 0, and another carry is generated. Another carry is generated here, and finally this carry and this carry, if you add, then it will be 2. So answer should be 20A. After adding these three numbers, our real answer should be 20A. But this result is stored in A, and this value in A register, and this value we have stored at 40H memory location. That's why at the 40H location you will find 0AH. We will not get this 2. So this program will work perfectly if we are having a number, and while adding those numbers no carry is generated. In that case you will get the correct result. But if we are having the numbers like set 2 or set 3, in which case when we are adding the numbers and carry is generated, in that case we are not getting our result correct. Why we are not getting the result correct? Because in this program we have not considered a case when carry will be generated. So we have to rectify our program, and we have to include some instruction which will just verify the carry flag, and according to the carry flag we will make certain changes in the program so that we can get the correct result. So that program we will just discuss in next lecture.